When you consider an offshore lightning arrestor installation, there are different factors to consider, especially regarding grounding. We mainly use lightning arrestors on board maritime vessels for incoming antenna cables, especially cables coming from an outside exposed area to inside equipment. Before initiating the installation process, conduct a thorough assessment of the vessel. Identify key areas, such as the mast, antennas, navigation equipment, and other vulnerable points where lightning strikes could potentially occur. The lightning protection system on board a vessel contains multiple layers of protection equipment. These elements play different roles in the overall safety protection of a ship against lightning. The damages and impact of a direct lightning strike are the sources of lightning hazards. Hence, the protection system needs to mitigate the bolts while contacting the ship's surface. Moreover, the system needs to move the lightning at one point instead to protect the other areas too. A surge in the voltage causes critical components of the vessel operation system to go ineffective. Hence, the lightning protection setup needs to account for surge protection with the bonding arrangement. It also includes the diversion of the lightning strikes to a safe zone on board for further handling. The side risk of a lightning incident on board is the arc flashes on the systems. These will instantly lead to fires or blasts in the nearby area, causing fatalities and losses. Hence, direct bonding arrangements for all the equipment to a common point becomes essential. The dissipation of lightning into the hull will impact the people on board with immediate shock. These shocks will range up to several thousand volts, immediately killing everything in sight. Hence, proper grounding arrangement for all the accommodation and other spaces takes care of this hazard. The lightning protection installation systems are the best explanation of how ships are protected from lightning. The installation starts at the top of the monkey island from the radar mast, progressing towards the hull. The critical elements handle lightning from the time of contact up to its final mitigation. The air terminal at the mast will be a single rising element with additional electrodes as a cluster. The element gathers the lightning and directs it towards a safe zone for grounding into the electrodes. The voltage rating of these terminals goes up to 500 to 750 kV for modern systems. While the main body is of steel, the inside consists of a series of resistors to lower the intensity. The outer shielding consists of a fiberglass rod that shields the inner elements. These are secured onto the mast base with the help of U-bolts and a rubber clamp for security. The air terminal further connects to the bonding cable that carries the lightning safely into the water. The crucial components of this unit summarize into upper termination unit, U-clamps, fiberglass rod, lower termination unit, bonding conductor, bonding cable. The bonding or the shielding cable connects the air terminal to a immersing clamp that acts as ground screws. The surge suppression unit contains individual breakers and fuses, and the interconnection to a surging box. These contain single-phase and three-phase power supply protection kits of different ratings. A common example is that of the trademark 3DR 100 kA 385 Ni 100 surge protection setup. The surge protection box also has connections from several critical elements. These wires are of the equivalent rating for the shielding cable. The cables further connect the box to the single bonding point for the grounding of the lightning into the water. The bonding and earthing arrangements vary as per the size and nature of the vessel. An oil tanker bonding screw at the hull is different from that of a bulk carrier. A simple silicon or bronze screw electrode has a higher rate of reduction in comparison to other designs. These bonding connections are the final point of contact where the lightning safely dissipates into the water. Hence, the safe passage of lightning finally ends with grounding into the sea. Your telecom equipment is now safe from surges and lightning strikes, improving the reliability, durability and efficiency of your telecom systems. Stay tuned for more videos on telecom, IT and ELD systems for harsh and hazardous environments.